Hello, and thank you for joining me. My name is David Blanco. I'm the Business Development Manager here at AUTOSOL, and today I'll be presenting and then demonstrating AUTOSOL's Edge solution, eACM. eACM is a way to communicate to native protocols and convert them to MQTT or MQTT Sparkplug B. So without further ado, here is our agenda for today. First, I will talk about and then demonstrate AUTOSOL's products on the edge, as well as go over our roadmap to let you know where we're taking the product. So, AUTOSOL on the edge. eACM, pictured here in green, is a lightweight piece of software that fits onto almost any edge Linux box. This could be a cell modem, this could be a radio, this could be a smart switch, or a smart router. The native protocols of RTUs and PLCs commonly used in industrial control systems reside inside eACM. So once you put a tag list of desired I/O inside of eACM, it does the traditional demand response with the end device. Then it only sends up the values that have changed via the report by exception capabilities of the MQTT protocol. This data is then sent to a central broker where other applications can subscribe to the data. So that way each application gets the exact data that it needs. So this way we can send data straight to an HMI or a data warehouse to feed an ERP system, an analytics system, whatever you or your clients may need. So this is kind of the 10,000-foot view of the application. So now let's take a deeper look at it. So eACM is a way to communicate to RTUs and PLCs on the edge and convert it to MQTT, to allow you to reduce the bandwidth consumption of your applications back to your SCADA or get higher resolution data than is currently possible. Now, eACM specifically supports multiple protocols and multiple devices at the same time. What this means is that if you have a scenario where you've got a eACM installed, let's say on a radio in the field, and there's 4 rocks on that site, eACM can communicate with all 4 rocks simultaneously and convert the protocol to MQTT and push it up the network to a broker. Also, eACM could take a scenario where it's, let's say, 3 rocks, a Modbus device, and a total flow device. All of those can talk simultaneously to eACM, and that data can be shipped back up the network. We also have the ability to add deadbands and alarms on the tags. So with MQTT, sometimes you need to set deadbands. So if you're watching something like a pressure, well, that's always going to be changing by the 100th of the 1000th of a value. So if you don't want just constant spamming of the data, you can set absolute or percent-based deadbands. And we'll do a live demonstration of this capability during the demo portion. You can also set alarms, so that way if a value goes over a certain threshold, it will automatically send up the data to the broker every time it changes, so your SCADA system alarms won't miss anything. The protocols currently supported by eACM are as follows. We have the full ROC and ROC Plus suite that is available in the oil and gas industry. So FlowBoss 104, 107, 407, 503, and 504, as well as ROC 306, 312, 364, 809, 827, and 800L. A ROC 809 will be part of the demo portion at the end of this presentation. We also support a number of Modbuses, of course, Modbus TCP, generic ASCII, and RTU, as well as a number of extensions for Autopilot, Enron, Daniels, Flow Automation, Omni, SCADAPack, and Lufkin. We also support the AVB Total Flow device. So for those of you unfamiliar with MQTT, I have a very brief explanation of how eACM utilizes this protocol. So when we're in the field, like this demonstration here, eACM pulls the end device in its native protocol, and it's looking for a change of value. So as soon as the value changes, that is when eACM is going to send a message up to the broker. If the value doesn't change, eACM doesn't publish the value up to the SCADA system. Now there's an enhancement to MQTT called MQTT Sparkplug B. Now what this one does is he also continues to pull the end device natively. But instead of just looking for a change, he only publishes data once every X number of seconds. This is a configurable amount. So my guy's going to pull them for 8 seconds, and then at the end of 8 seconds, he's going to publish all of those values So 8 records, all saying 150 pressure, back up to the SCADA system. This allows you to have a high resolution image of what's going on in the field in between poles, basically. So MQTT allows us to do real-time report by exception. So what usually happens in a SCADA system, let's just say I have a rock with multiple meter runs and a lot of other stuff happening out there, maybe a pump. So I've got about 1,000 I/O on that rock. Well, traditionally in a SCADA system, I'm going to say to my HMI, okay, here's 1,000 tags I want. I'm going to send the list of all 1,000 down the network to the device. The device will process it and send the whole 1,000 list back up the network. Well, if just 150 of those points change, pipe diameter won't change if you're pulling that in, meter ID won't change if you're pulling that in. So if only about 150 of those I/O changed, you kind of just had a 850 tag overhead on that one message. And that builds up over time, especially if you have a very busy field. What MQTT does is, since eACM is polling the device at the RTU or PLC level, we're not sending a big list of tags down the network. We're only sending the values that changed up. And with Sparkplug B, we're able to poll and publish at different intervals. So we can get a higher resolution picture. So for example, eACM can poll the end device every second, but using Sparkplug B, you can just publish it every hour. So you'll get 3,600 records, I believe, published back to your SCADA system. And that data will have an 85% compression rate on it as well. eACM also comes equipped with the ability to do loss connection buffering and backfilling. If your eACM device in the field detects that it loses connection to the broker, then it will automatically try to connect to a redundant broker, as well as, if that fails, it'll then store the data locally. And once it has a connection back to a good broker, it'll publish all the data that it gathered during the outage. So here's a little comparison on the savings between traditional SCADA protocols like Modbus and MQTT report by exception. So here we have a SCADA system that was monitoring a very important valve over a 24-hour period in the field. So over the course of the day, the traditional demand response from the SCADA system, have you changed, have you changed, have you changed, and then no, 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 back from the valve, was replaced by MQTT just listening locally and then alerting the SCADA system, hey, he opened, hey, he closed. So over the course of the day, Modbus sent 35,000 packets, and MQTT only sent 588. Probably, I would say 500 of those are probably just pings between the MQTT edge device and the broker to make sure that there was still a good connection. Now, in terms of actual bandwidth, it took 2 megabytes to monitor that valve that changed twice a day, open, close. And it took MQTT 51 kilobytes. So that's over a 90% compression rate, or a 90% reduction on bandwidth consumption for just one valve. So what happens if we kind of scale it up a little more? Well, this site had 389 tags coming in via Modbus. But once those same devices had MQTT on them, they went from consuming 8 megabytes a day, so kind of a lower resolution poll right there already, to 0.72 megabytes a day. So again, a drastic reduction of bandwidth consumption through the implementation of MQTT. So the benefits of deploying eACM is lower bandwidth, so you get that report by exception that we just saw the charts for. That's an enhancement to existing systems. Then you get something that we can't currently do with traditional SCADA systems, at least for remote sites in the oil and gas industry, is a higher resolution data backfill. So what is happening in the field between each one of your hourly polls or each one of your 15-minute polls? Well, eACM can backfill that data for you for tags that you deem valuable, like a pressure or a flow. eACM can also act as a broader platform for edge processing as well. So we can optimize processes in the field or address pain points for our clients. One such example of how we've done this is with an app we call Priority Forward. So the context for this app is, let's say that you've got a serial device, a FlowBoss 107 in the field, and he is connected serially to a radio, a 900 megahertz SCADA radio. And eACM is installed in that radio. So if eACM is going to pull that serial device, let's just say once a second or once every minute, well, what's going to happen when someone tries to come in with ROClink? ROClink is the configuration software for ROC devices. Or what's going to happen if an EFM server tries to pull that ROC to get EFM data? So priority forward is a way for two masters to be assigned to one slave. So eACM in this situation will be the secondary master, and any other process that wants to talk to that end device will be the primary master. So what will happen is if a technician wants to get in on ROClink, he would hit the radio on a certain port, and that would automatically shut down eACM to allow that technician access to the end device. And that's what priority forward does. Now, eACM is currently available on two hardware devices. The first is the FreeWave ZoomLink 900 MHz shortwave SCADA radio. This is a Class 1 Div 2 ABCD device with 1 GB of RAM and 4 GB of hard drive space. The other module, and the one I am using in this demo, is the FreeWave Zoom IQ. This is basically the radio, but without the radio in it, so it acts as a smart switch. It too is industrial, as well as has 1 GB of RAM and 4 GB of hard drive space. Now, in terms of getting the data into a traditional HMI, right? So there's a lot of HMIs that are not equipped to handle MQTT or MQTT Sparkplug B. Now, the ones that eACM has been successfully integrated with is Ignition, because Ignition has built-in MQTT and MQTT Sparkplug B modules. However, AUTOSOL has created a software that is a MQTT to OPC bridge. So we see on this diagram in the middle here that eACM can now pull the device in the native protocol, publish that to a broker, and then our bridge application can take that MQTT data and present it as OPC to traditional OPC HMIs. So eACM is compatible with ClearSCADA, Signet, Telvet, Wonderware, VT SCADA, OSI. So where are we taking eACM? In the next release of eACM, we will have the ability to do redundant broker connections. So this will be simultaneous connections as well as a primary and backup scenario. We will also be able to publish based off of a trigger value. So what I mean by this is eACM can monitor a certain tag for you, and if it goes out of its deadband, so if it goes past a threshold, you can then trigger an instant publish of another group of tags outside of your normal publish rate. So you kind of take an instant snapshot based off what's happening in the field. So something else that we've run into is, of course, let's say you've got dozens of eACMs in the field, like some of our clients do. Then how do you manage them all? So we have a beta version available of the API Mass Manager app. This is a server-side application. It is not in the field. It is on a machine in your office or on the cloud. And it lets you do individual configuration of eACMs that are deployed in the field. You can also send software updates and do licensing. There's also the capability of mass configuration of multiple eACMs. And of course, there's always the option to create other plugins between the MQTT data that we're getting from eACM and any other process you may need. So MQTT to OPC was the first obstacle we overcame. And if there is a way that you would like to use MQTT data that you did not see in this presentation, let us know. AUTOSOL is a software company. We'd be happy to help you with that. So here is a kind of a quick screenshot of what some of the API Mass Manager interfaces look like. As you can see on the right there, it's basically object-oriented configuration. So you can even have devices that share connections, or if you've got a really pristine implementation of your SCADA system, then you can have tag groups shared between devices as well, although I have not seen an instance where that would have been beneficial. So you can also do, let's see, individual mass configuration as well as updates. So by updates, I mean the adding new protocols to the eACM installation, or adding new Modbus register groups. So the protocols that we're going to be tackling next, not necessarily in this order, is going to be DNP3, Control Logics, and DF1. If you see a protocol that you are interested in, please let us know. We're also exploring other hardware options. So we have the capability to install eACM on these pieces of hardware as well. The Cisco 829 router, the Moxa 8100 modem, the Sierra Wireless RV50, and the RAD SecFlow. Now, because eACM is so lightweight, we are roughly 30 megabytes in size. Currently on the Zoom series, we're 30 megabytes on a 4 gigabyte hard drive. So there's a lot of room in that sandbox for other people to come and play with us. So eACM has a local API that will allow us to take data from the RTU and PLC and then present it to other apps locally on that box. Now this can be done through the API, or because eACM can publish on redundant brokers, we can publish to a broker that's installed locally on the Zoom IQ, like Mosquito, and then the third-party app can subscribe to that broker and get data that way. And then eACM can also still publish data to the broker in the cloud or on the server. Now we'll enter the demo portion of this presentation. So here is what I'll be doing during the demo. I have my laptop running two HMIs, Clear SCADA and Ignition, and I have a Zoom IQ in my test lab. This Zoom IQ is plugged into a switch where I have a Raspberry Pi running a Modbus simulation. I have a ROC 809, and I have a TotalFlow. So Zoom IQ will be talking Modbus to the Raspberry Pi, ROC protocol to the ROC, and TotalFlow to the TotalFlow, and then converting all of these simultaneously to MQTT and MQTT Sparkplug B back to my HMIs. So now to the demo. All right, so each instance of eACM runs on a little local web server, so I can get to the website. If I go to this IP address, this is my FreeWave Zoom IQ box here. So I'm inside of the FreeWave box, and eACM just sits on the port 8080. So we don't block any traffic happening. We're just on the box interacting with the end device. So we can see right here, eACM is currently running, the status is good, and here are all of my devices that I have inside of eACM. So what I'll be showing you today is the ABB TotalFlow, the Modbus, the ROC 800, and I'm also pulling the SCADA pack, and we can talk about him a little later. So I'm just going to go into this ROC device because he's pretty common. And for those of you familiar with ROC, these unit and group addresses will be pretty familiar, as well as being able to set the message link. And the connections are also pretty familiar, right? Here's the IP address of my ROC, here's the port I interact with it on, and here is how often I actually tell eACM, go and poll this device. So the ROC will poll every 2,000 milliseconds, 2 seconds, and my Modbus device will poll every 1,000 milliseconds. So eACM can also, you can do multiple devices of different protocols and stagger and change how often they poll. So this is my Modbus device, and for those of you familiar with Modbus, here's the TCP option, RTU. Here's all the different register set types I mentioned earlier, as well as some special addressing types. So there's Luckin, like I mentioned, SCADA pack, 2 bytes as well. And then there's also the tags here. So on tags, I can come in here and change, an individual tag value if I wanted to. Or I can do a mass export from one system and import it into another system. So for example, I'm just going to remove some of these tags here. Oh, well, let's just say I want those tags back. So I'll go and find what I just made, my Modbus tags 5, open, replace from CSV, and all of my tags are back. Now, over here in the tree, I also have the capability to add, copy, or delete items. So if I have a lot of Modbus devices, I basically just made a templatized version of Modbus here for me. So here we go. Here's the device, the connection, so I don't have to go in and manually redo each one now. And of course, for the tags, it's the same thing that we just got done doing here. I can import from CSV. So, and he's gone. So up here, I can start, stop, and of course, just reset. If I make a lot of heavy changes to my system, I'll have to reset. eACM runs with the configuration that was last good. So if you hit play or reset and there's an error, it won't run that until you fix it. Now, I also have the capability of doing different types of publishing. So there's basic MQTT and then MQTT with Sparkplug B. So let's take a look at MQTT first. What MQTT does is eACM polls these devices and has registers of tags, right? When that value changes, this publisher, the MQTT publisher here, just publishes it when it changes. So we'll see that it's publishing here to this IP address, 56128. That is my laptop. And it's publishing on port 1883. So let's go ahead and take a look at clears data to see how this data is coming in. So here is a clears data system that is capable of receiving MQTT only, not Sparkplug, MQTT data. So my registers 40,001 to 40,006 are basically counters that go from 0 to 100 and update every second. So this top guy has no deadband, and we see every second his value changes. 40,002 has a 5% deadband set and no alarms. What this means is when this value changes by 5% of its current value, not the range of values, not 0 to 100, but just this value by 5%, publish. And then eACM triggers MQTT, and MQTT sends it up. Now this guy is a 10% deadband. So that's why these are not in sync, because this is a 5%, this is a 10%. They will meet up eventually, but that's why they pull at different rates, because this is 10% of the absolute value. Now this guy's pretty easy. Absolute value 5, he'll change at 70. This one's absolute value 15, so he'll change next at 75. And this guy is where I have some alarms set here. So he changes on an absolute deadband of 10, so he'll change at 80 next. But when he gets to 90, he'll be an alarm. So what eACM will do is he'll say, okay, what's your alarm? 90. So when he gets to the value of 91, 92, 93, every value above this alarm will trigger a publish. There we go. So this way, the HMI will not miss an alarm. Same thing with the low alarm. If this value is below 10, it is considered an alarm, and eACM publishes every change detected on that tag after eACM polls it. So he'll poll basically every second until he gets back to 10 seconds. And at 10 seconds, he'll re-engage his deadband and only update in the HMI on an absolute 10 value basis. So in a couple seconds, we'll see this guy transform back to 20. And there we go. So what I have down here is just basically I'm pulling a Modbus device, I'm pulling a ROC device, and I'm pulling a total flow device. And I just did this to show you that I'm pulling them all simultaneously on eACM, and though I didn't think I would here, I'll go ahead and do it now. This is my SCADA pack that I'm pulling as well. So I've got some kind of, I was just playing around with some of the tags. So eACM's pretty good at handling, all the standard Modbus modifiers that you would need to use as well. So that is basic MQTT. Now I'm going to transition to MQTT Sparkplug B. So that is going to require me to use a different HMI, and I have chosen to use Ignition for that portion. So let me go to my eACM here and change out what publisher I'm using. So I'm going to disable MQTT, enable MQTT Sparkplug B, and we'll see right off the bat there that there's a lot of differences between these two configurations, right? This is pretty basic. This is just, hey, if the value changes, send it here and here. This is a little more sophisticated. Hey, if the value changes, send it here and here, but only send up a report every 10 seconds. So this is where MQTT and eACM get very, very flexible. I could have a device that's got a 1 second poll rate, but a publish rate of 1 hour. So I haven't done the math yet on how many milliseconds that is, but I could put 1 hour here, which means that MQTT Sparkplug B would then send up 3,600 backfilled data to my HMI at a time. But because I don't want to make y'all wait an hour, I'll go ahead and just do 10 seconds. So I won't publish MQTT values unless they are out of alarms to my SCADA system, except every 10 seconds here, or every 10,000 milliseconds. And the device I'm going to use is going to be this Raspberry Pi device, because that is the register set I have configured in Ignition to store history already. And since this Raspberry Pi and this Modbus device are actually the same device, I'll go ahead and change that too. So before I hit restart, I just want to go back to ClearSCADA here and say, see how they're all still polling? I've made changes to the configuration, but I have not committed them yet. So this is a way to make sure that even if there's an error on your configuration, it won't interfere with your SCADA system. So these values are still polling, but once I come here and just restart, so right, I've enabled Sparkplug B, disabled MQTT, and now my ClearSCADA falls silent. I've also got this device activated now, and this device disabled. So we'll go ahead and look inside of Ignition. And oops, kind of already tilted my hand here. So let's go ahead and explore this viewer to see what's happening over here. So inside of my Sparkplug B publisher, I have something called a group ID and a node ID. So the way that all of these tags will automatically, all I have to do is send the right configurations. I have a group ID, a node ID, a device ID, and some tags. I send them to Ignition, and the tags will automatically show up inside of Ignition based off this path. So we will see a path inside of Ignition that says eACM Sparkplug B, travel demo. It'll say Raspberry Pi device, and then it'll have a tag of 40,001 because this alias is what shows up in Ignition. So here we go. Edge nodes, eACM Sparkplug B, travel demo, Raspberry Pi device, 40,001. We see this little scroll here on the left. That indicates that I have history collecting on that guy, and that is what is showing up here in the chart. So what we see here is once every 10 seconds, this guy updates. So see, his value just changed. And what's happening is his value is staying the same, right? He's stuck at, it looks like 40, 42 maybe. So every 10 seconds, he gets an update. And all these sawtooth values are the backfilled history that comes up because my Modbus device is polling every second, but my publisher is publishing every 10 seconds. So I get one real-time update followed by 9 historic backfills. And this guy will just chug along until I shut something down or change something. So at the end of the day, this is what eACM does. It takes the native protocol, converts it to MQTT, and allows you to control how much bandwidth you save and how much high-resolution data you get. So this is ideal for people who have the need to fill in data both for a SCADA system as well as an analytics system. I know I've been to a couple trade shows where companies that do analytics have said, and I'm quoting here, you can never have too much data. So I'm going to go ahead and end the presentation now. I thank you all for your time. Please feel free to shoot any questions or comments you have about our product to AUTOSOL. Our contact information, I believe, is located here on the page. Again, I'm David Blanco, the Business Development Manager. You can reach me at 281-286-6147. Thank you very much, everybody, and have a nice day.